Good morning all. So in today's class we will begin the module 1 for vector calculus. So the module is on vector differential calculus. So first module we will be looking at vector differentiation, and the second module we will be looking at vector integration. And in today's class, so we'll start with what is called velocity and acceleration. So first of all, we'll define what is called displacement. Now, using displacement, we will give the definition for velocity. So as you know, displacement is defined as a change in position of an object. So it is defined as, so that is the change in position of an object. And displacement, so it is a vector quantity so therefore it has a magnitude and direction. So the displacement is defined as the change in the position of an object. And now let us give a value for the position function, and let us take t to be the time. So if the scalar variable t denotes time, and if r is the position vector of a moving particle p, then displacement is given by the change in the position. So we are having t to be the variable denoting time, and r എന്ന് പറയുന്നത് നമ്മുടെ position vector ആണ്, and you have a particle p which is moving along the position given by the vector r. Then the displacement is given by change in position. So then delta r, so that denotes a change in position. So delta r is the displacement of the particle in time delta t. And this is how we define the displacement. So displacement is the change in position. Now once we have displacement, velocity is defined as the rate of change of displacement. So therefore ഇപ്പോൾ നമുക്കൊരു ചെറിയ interval of time in delta of t, the change in position or displacement is given by delta r. So the vector, so when you take delta r by delta t, so that is the change in position by the change in time. So this gives the average velocity of the particle during the time interval delta t. So therefore delta r by delta t is the average velocity of the particle during the time interval delta t, and the instantaneous rate of change of displacement is called as the velocity. So when you take limit delta t tends to 0, delta r by delta t, So this gives us the velocity of the particle p. So let us define velocity. So if v represents the velocity vector of the particle p, then v is given by limit delta t tends to 0, delta r by delta t, or that is dr by dt, or this limit gives us the, so this is the derivative of your position vector r. So therefore the velocity is given by, so if r of t is a position vector, then the velocity is given by r dash of t, and the direction of v is along the tangent at p. So that will give the direction of the velocity vector. So if r of t is a position vector, then the velocity vector v of t is given by, so that will be equal to r dash of t. And now let us define acceleration. Now acceleration is the rate of change of velocity. അപ്പം നമുക്ക് v എന്ന് പറയുന്നത് വെലോസിറ്റി വെക്ടർ ആണ്. അപ്പോൾ നമ്മൾ ഡെൽറ്റ v എടുക്കുമ്പോൾ that will give the change in velocity. So when you take delta v by delta t, that gives the average velocity. Now when you take the instantaneous rate of change of velocity, that gives the acceleration. അപ്പം നമ്മൾ velocity define ചെയ്ത പോലെ തന്നെ. So if delta v is the change in velocity, during the time delta t, then delta v by delta t is the average acceleration, and if the vector a represents the acceleration of the particle p, then a is given by, so that will be limit delta t tends to 0, delta v by delta t, so that is equal to dv by dt. So that is the derivative of your velocity vector, or that is again equal to d by dt of dr by dt. So that is d square r by dt square. So therefore a of t, the acceleration vector, is given by d square r by dt square. So that is r double dash of t. So that's how we obtain the velocity vector and the acceleration vector. Look at an example. So you are given the position vector r equal to sin ti plus cos tj plus tk. Then we are asked to find the magnitude of d square r by dt square. So let us find out the vector r dash of t first. So r dash of t will be, okay, let me write it as dr by dt. So differentiate component wise. ആദ്യമായി component differentiate ചെയ്യുക. So that will be cos ti, then minus sin t j plus k. Now differentiating once again, so d square r by dt square will be, so take the second derivative, so you'll get minus sin ti minus cos t j, and here the derivative coefficient 1 ആണ്, so derivative will be 0 k, so that will be equal to minus sin ti minus cos t j. So therefore the magnitude of d square r by dt square, that will be root of minus sin t whole square plus minus cos t whole square. So that will be root of sin square plus cos square t, so which will be equal to root of 1. So the required value is equal to 1. Next question is, show that if r is equal to a sin omega t plus b cos omega t, where a, b, omega are constants, then we need to show that d square r by dt square is equal to minus omega square r, and r cross dr by dt is minus omega a cross b. So here r is the given position vector. ഇനി എയും ബിയും കോൺസ്റ്റന്റ് വെക്ടേഴ്സ് ആണ്, ആൻഡ് ഒമേഗ ഇസ് എ സ്കെയിലർ. ഓക്കെ, so that is your given vector r, so that is a sin omega t plus b cos omega t. Then we need to calculate here dr by dt and d square r by dt square. So let us start with dr by dt. So dr by dt will be a constant vector ആണ്. So when you take the derivative, so differentiate the terms involving t, so you will get omega cos omega t minus vector b omega sin omega t. So that will be omega a cos omega t minus b sin omega t. And now let us find d square r by dt square. So differentiating once again, you will get omega. So this is a, so derivative cos omega t will be minus omega sin omega t, then minus b omega cos omega t. Now minus omega is common in both the terms, so taking out that, you will get minus omega square a sin omega t plus b cos omega t. So as you can see, a sin omega t plus b cos omega t is the value of r, so that will give minus omega square r. So therefore d square r by dt square is equal to minus omega square r. So that is the first part of the problem. Now next you need to find r cross dr by dt. So r cross dr by dt, so r is a sin omega t plus b cos omega t. So cross r will be omega so a omega cos omega t minus b omega sin omega t. Now we need to take the cross product of these two